Hello, everyone, and welcome back. In this lesson, we are looking at solving rational inequalities. And what we mean by that is inequalities written in the form ax plus b over cx plus d, or inequalities written in fractional form. To start off our discussion, we'll look at the graph f of x is equal to 1 over x. This is a very simple rational function. And we know that for x equals 0 here, the graph is discontinuous. That is, there's no value when we input 0, which is why the graph is split this way. And we want to answer the question, what is the solution set for 1 over x is greater than 0, meaning for what values of x is the function positive? And looking at it, the function 1 over x can only be greater than 0 if, and this if means if and only if x itself is greater than 0. So if x is positive, then the function will be positive. And as you look at the graph, you can see here that as long as x is a positive number, such as 1 or 2, then the values on this side of the graph are positive. That is, the range values are positive. So as long as x is greater than 0, then the function has positive values. And we could write this and leave it as that. Or we could write it in another form saying x is greater than 0, which means we start with an open interval since it's greater than 0. And x continues to positive infinity. So these are all the values. Of course, you can't reach infinity. It's just an idea there that once you start at 0 and you keep going. So x is greater than 0 is a solution set for this particular question. And we can also write it this way. Now let's look at another one. Here we have the function f of x is equal to 1 over 2x plus 3. And we want to answer the question, for what values of x is this function less than 0? So we have 1 over 2x plus 3 is less than 0, which means for what values of x is this function negative? To do that, we need to solve the denominator. So let's solve the denominator. So we have 2x plus 3 equals 0, which means that 2x is equal to negative 3, and therefore x is equal to negative 3 over 2, or negative 1.5. So if x is equal to negative 1.5, as you can see on the graph, then this value cannot be included in the domain. Hence, the graph splits here. But in terms of what values of x would make the function negative, as you look at the graph, you'll notice that from this point onward, going down in this direction, then all the values on the range are negative. Notice here. So for all x starting at negative 1.5 and going that way, then all the values that we need are negative. So the function would be negative, would be less than 0 if we start at x equal 1.5 and go that way. So now, to write that solution, we would say that x would need to be less than 1.5, negative 1.5. And we can also write that as opening an interval here and saying, since this value can't be included, so we can't include it there. So negative 1.5, it's an open interval, we can't include this value. And then we go this way, so x would be headed to negative infinity. So pretty much that is the idea. X is less than negative 1.5, that's our solution. All x less than negative 1.5 would give us a favorable answer in this question. But there are other questions that we need to look at. So let's look at this one, for example, that says, what is the solution set for x plus 2 over x plus 1 is greater than 0? And remember, greater than 0 here means positive. So what values of x would give us positive values in this function? Well, to do that, we need to do two things. First, we need to solve the numerator, and we also need to solve the denominator. Now let's solve the numerator first. So we have x plus 2 is equal to 0, which tells us that x is equal to minus 2. And then let's solve the denominator of x minus 1 equals 0. And that gives us x is equal to 1. Now, once we get these two values, we need to set up a number line that we can use to test our results. So we're going to put these two numbers on the number line. Let's start with a 0 here. Let's start with a negative, put our -2 and our -1. Now let's discuss our -1 a little, our positive 1 a little bit. X cannot be 1 because if we put 1 here, then this function is going to be undefined. This whole thing is going to be undefined because this denominator is going to be 0. So this cannot be included. So let's exclude it right there. This 2, however, x can be -2. So if we can include this one. And what we need to do now is that we need to test the regions of the graph by looking at, we can do a simple sign analysis and check out what's going on in the graph. Now let's write this down. X plus 2 over x minus 1. Now let's suppose that if x is 0, what's going to happen if x is 0? If x is equal to 0, then we're going to have 0 plus 2 over 0 minus 1. That means we're going to have a positive divided by a negative. That's negative. So in this region, here we're going to have a minus. Everything in this region is going to be negative. And looking at this region over here, if x is equal to, let's say, -3, then -3 plus 2 over -3 minus 1. This is going to be negative. This is going to be negative. Negative divided by negative is a positive. So this section of the graph is going to be positive of the number line. Going that way is going to be positive. In this section here is going to be negative. What about up here? Let's check it. So suppose x is 2. Then 2 plus 2 over 2 minus 1. That's also positive because this is 4 and this is 1. So we have a positive here and we have a positive here. And the question says the solution set for which x plus 2 divided by x minus 1 is positive. So we have a solution in this region and we have a solution in this region. So we could write our solutions as here, starting, we can include this value. So we can say x is less than or equal to -2. That's one solution here. We can also write the solution x is greater than 1. Once x is greater than 1, then we realize that it's giving us positive values in this direction. So that's also a part of the solution. Inside here, there would be no solutions because this part of it is negative. We can also write this. If we want to write it, x is less than -2, so from negative infinity, the 2 is included, so we use a square bracket there. And for this one, x is greater than 1, so we start with an open bracket here, write the 1, and it goes to positive infinity. So this is how we'd solve a question like this. First thing you needed to do was to solve the numerator. Solve the denominator. Those give you some values that you put on your number line. And once you get those numbers on your number line, you start checking each region by doing a sign analysis to see where your solution would fall. So remember, greater than or equal to 0 means positive. And so we look for where we'd have positive results, and we'd have positive here and here. Let's look at one more. What is the solution set of x squared minus x minus 6 over x minus 1 is less than or equal to 0? What is the solution set for this? So again, we will need to solve this, and we will need to solve this. Now solving x squared minus x minus 6 equals 0. Of course, we can reduce it to x minus 3, x plus 2, which gives us x is equal to 3 and x is equal to -2. And of course, we solve the denominator, x minus 1, which tells us that x is equal to 1. Now remember, if x is 1, then this denominator, this blows up our denominator because we'd have an undefined value. So let's draw our number line. and see how we can analyze it using our sign analysis to see where our solutions would be. So let's write in these numbers on our number line. And I like to start by writing 0 first. Then we have 1, and we also have 3, and we have -2. So we have a number of regions to consider. Let's look at this one first. 1, remember, cannot be included in the solutions. So we start by putting that over it. And what about 2? -2 can be included since we're dealing with a double condition here. We use a shaded circle. And also for 3, we use a shaded circle. So we have a number of places to check. We can check this region, we can check this region, we can check this region and that region. So there are 4 regions, 1, 2, 3, 4. Let's begin by checking them one by one. Now, what we have is x minus 3, x plus 2 divided by x minus 1, and we want to check them for some values. So let's start with 0. 0 is always easy to use. So if x is equal to 0, then we're dealing with this region right here. Then we'd have a negative here, we'd have a positive here, and we'd have a negative here. And the negative divided by a negative, here we have a negative times positive, that's negative, and negative divided by negative would be equal to positive. So inside here would be positive. What if x is in this region? So suppose x is 2. If x is 2, this is going to be negative, this is going to be positive, and this is going to be positive, which means that we're going to have a negative times a positive is a negative, and a negative divided by positive is still negative. So in this region, we're going to have a negative. Now, what about this region up here? Suppose x is 4. If x is 4, then we're going to have a positive here. We're going to have a positive there, and we're going to have a positive here. So in this region up here, we're getting positives. Now let's do the last region down here. Suppose x is -3. If x is -3, then we're going to have, let me just erase these a little bit. All right. If x is -3, then we're going to have a negative here, a negative here, and a negative here. And negative times negative gives us a positive, and a positive divided by a negative gives us a negative. So this region will also be negative. So we have 2 negative regions and 2 positive regions. Now, the question asked for the solution set for x when the whole thing is less than 0, which means that the whole thing is negative. And so we want to look at the solutions here. We have a solution right here, and we have a solution in this region. So we have one solution right here, and we have a solution going this way. Now let's write those down. The solution for this part is going to be x is less than or equal to -2. We can include this value. And the solution for this part is x lies between, notice we can't include that one. So x lies between, let me just erase this just a moment. X lies between 1 and 3, which we can include. So these are the solution sets for this particular question. And we can also write them alternately as, since x is less than -2, then we know that x is heading toward -infinity. And we start at -2. -2 is included. So we use the square bracket. And in this case, here, x lies between 1 and 3. This one can't be included, so we use a curved bracket. And 3, this 3 can be included, so we use a square bracket on that side. So this is how we go about solving rational inequalities. You may need to get some more practice to make sure you get the skill tied down and to boost your understanding of it. So make sure that you get some more practice. And of course, if you haven't subscribed, then please do. And thanks for watching.